Okay, let me run through this one more time. So we have m squared minus 64. Both of those are perfect squares. If we multiply m times m, we get m squared. If we multiply 8 times 8, we get 64. Okay, so little handy dandy rule is this is called difference of squares. Okay, anytime you have this scenario, we can break it up into m minus 8 and m plus 8. Because think about it. If we FOIL that out, really anytime you see those exact same numbers right here, if we have the same m here and the same 8 here, and the only difference is a negative and a positive, well, those numbers are going to cancel out 100% of the time. Because think about it, negative 8 times m is going to give me a negative 8m. 8 times n is going to give me 8m. Well, that's going to cancel out. Okay? Good? Shh. Girls. Now, what's the square root of 81?
9. Negative 9.
What about z squared?
Z.
It's going to be z.
Oh, you gotta put positive 9, I don't like it.
Now, if we go 9 squared, we get 81. And if we go z squared, we get z squared. So we're right on that. So we have perfect squares right here across the board. Right?
Do we pick the lowest one?
Subtract it, and then like what do you do?
Well, let's talk about this. We figured out we have two perfect squares right here. Okay, that same rule still applies when we went over to begin with. Remember, if you figure that out, you can just write down whatever it is, and then all you need is a negative and a positive, right?
Is that the answer?
No.
No, I know what we're gonna do next. You got
So now, shh,
y, and then
hush,
plus 4.
hush. Okay, that same rule still applies. Just make one of them negative, make one of them positive. So I need a negative 9z,
Boogie.
and I need a positive 1.
What do we want as the answer?
Now, since I have a common factor of 3b, what's going to be left? Well, I'm going to have b squared. What's going to be left out of the 27b? 9. Okay. Now, is this b squared a perfect square? Is this 9 a perfect square?
No.
Think about it. It is.
Wait, what?
How do I get to b squared? I just multiply it by itself.
Yeah, B.
How do I get 9? I multiply 3 times 3. So, now that 3b that we factored out to begin with, leave it out there. We're done with it. We're not messing with it anymore.
Is that the answer?
No. Okay, so we figured out that we have a difference of squares right here. Okay? So, what do I need to do? What do I need?
B squared plus 9.
I need a b plus 9 and a b minus 9. And that would be your answer. They typically like to use the numbers like a squared minus b squared. Anytime you have this, they call this the difference of square rules. Okay? Anytime you have this scenario,
A squared plus B squared is C squared.
okay? Anytime you have this scenario, what you can do is we can factor this so that scenario in which you have m squared and then 8 squared. All right? You can break it up so that we have an m plus whatever that number is. Okay, in this case it's going to be 8. And beside of it we can have m minus 8. So, next thing, let's see if we have a greatest common factor between these two numbers. Well, we do. We have a 5x, okay? Now, if I factored out a 5x from both of those numbers, what am I going to have left? I'm going to have x squared.
And you're going to have a negative 4.
I said it first.
Okay, good.
Wait, where's 4? Wait, what? Oh, because
Here's another side rule. It doesn't always have to have the variable first. Okay? Shh, hush. Okay? It does not matter all the time. Daniel, put that up. All right? So in this case, our rule still applies. Okay?
Real quick, can I go to the bathroom?
quickly.
Why do you write that in a nice type of
Okay? So it does not matter. Our same rule still applies. It's okay. Our variable does not have to lead off always. Okay? So, what's the square root of 256?
16.
Good.
32.
16. Sorry.
And then, of course, we're going to have our n squared. If you square that, that gives us n to the fourth. Okay? So 16 squared gives us 256. And n squared gives, well, that gives us n to the fourth. Pretty simple, right? Now,
Yes, sir.
well, let's split this up. If we have 16 minus n squared, there's 1. And also if we have 16 plus n squared. Okay? Same concept, just a little bit more work. All right, now, we have one that applies to our rule. Okay, if you see that. If you see that minus sign, well, that means that it still applies to our rule. So, we need to break that one up. Those are perfect squares. 16, of course, and then n squared. So let's go ahead and break that up. And our kind of equation to the side is just going to stay there. Okay, that 16 plus n squared is just going to hang out. It's hanging out outside. All right? So, last thing you need to do here is, I need a 4 minus n. And I need a 4 plus n. Okay? Now what's left? Well, we have that 16 plus n squared at the very end. And that's your factored answer. Okay?
I got you, Schwaber.
You just keep going until that rule does not apply.
Oh, yeah.
What's that fling toward thing?
You get braces, KJ?
We know that 9 times 9 gives me 81. So I'm going to put my 9, put my square. Okay? D to the fourth. Well, I'm just going to bit d squared. If you raise that, that gives you d to the fourth.
Wait, did I not write Schwaber?
Guys, hush.
Just write Schwaber? I'm just asking, bro.
Okay? Now, listen to our rule. So since we have that, we can break this up into 9 minus d squared, and then 9 plus d squared. Okay? Now, the only one that applies to our difference of squares rule is that 9 minus d squared. Okay? So, we know that 3 squared is going to give me that, and d squared is going to give me that. Just keep that other one to the side. Don't worry about it yet.
13.
Okay?
13.
Okay? So now we know that we can go 3 minus d, there's 1, and then 3 plus d. And the last thing you need to do is,
You forgot the other part of the parentheses on the other one. Thank you.
last thing you need to do is go ahead and write your 9 plus d squared. It doesn't matter if you switch everything around as long as they match up. What you mean by, if you have what? As long as you have d minus 3 and d plus, yes. It's fine. As long as everything else matches up, you're fine. 3 what though? Good.
My x is 3.
Shh, what's going to be left?
Oh, Miss Silver, Miss Silver.
Shh.
Mrs. Robert.
Okay, so 9x is our greatest common factor, guys. Okay, so what's going to be left? Well, I'm going to have x to the fourth minus 4, yes.
Hey, I like your minus. It's like an underscore.
This applies to our rule. So we can break this up into, oh, I'm sorry. Okay? So we can split that up. Now,
Wait, what the heck is that?
that's a parentheses, sorry. All right? So, we know that we can break that up into x squared minus 2 and x squared plus 2. And what's left? Well, we had the 9x to begin with. Just leave it there. Now, we can't factor this out anymore, so that's going to be your answer. Okay? It's going to be 6. What's going to be left? Well, I'm going to have x to the third left here. Okay?
30x squared.
Well, now, plus 5x
5x squared.
squared. Okay, what about the 24x? No, it's not.
Negative 4.
Negative 4x. What about the 120?
Brad, you want some
Turn that off. You're not. Put it up. Put it up. So we factor all this out. Now the last thing we need to do is, well, that that 6 was in front of all this. Well, let's put that 6 in front of it. Now, let's look at these three numbers. Okay? Well, that's factored. It's all by itself. That's factored. Can we factor this?
Yes, sir.
How?
By factor.
That's a perfect square. X squared and minus 4. Those are perfect squares. So, all we need to write down is your x minus 2 and your x plus 2.
You lost.
Oh.
Now, what is left? Well, look all that stuff to the left. I got x plus 5,
Then you got your 6.
and I got your 6. And that would be your answer.